bone health by influencing that nutrient absorption like calcium and vitamin D. Are we having a good microbiome to take this calcium which we are prescribing? So gut microbiome producing beneficial compounds is a short chain fatty acids and vitamin K. They regulate inflammation and impact immune responses that control bone remodeling and remodeling cells, osteoclasts and blasts. Diets rich in fibers, prebiotics and protein support they help healthy gut bacteria, improving calcium uptake and vitamin synthesis, while a Western diet can produce inflammation, harming our bones. So this gut microbiome has got a direct action by releasing extracellular vesicles and an indirect action by interacting with the immune cells. We know that T helper cells and also regulatory T cells, as well as through the hormonal system by influencing the production of hormones like estrogen and parathyroid hormone. So the gut microbiome influences our estrogen metabolism, parathyroid hormone metabolism, IGF-1 levels. This is especially so very important for the postmenopausal women. Nearly 70% of the immune system resides in our gut. The microbiome regulates immune cells that directly affect the bone remodeling, and certain gut microbiota reduce the inflammatory T cell activity, promote a good regulatory T cells. They decrease osteoclast formation. A balanced microbiome supports healthier bone turnover. So what should we do to have this balanced gut microbiome? Now, the action of the gut microbiome are producing short-chain fatty acids, which are composed of acetic, propionic, and butyric acids, which are produced by the fermentation of indigestible dietary fibers by our gut microbiome. And they diffuse from the gut into the systemic circulation and plays a crucial role in regulating the bone metabolism. They are the signaling molecules that mediate interactions between daily diet, gut microbiome and host health. So they improve calcium absorption, they reduce inflammation, directly stimulate bone formation. So higher fiber intake, better short-chain fatty acid production, improved bone density potential. So they have got various actions, these short-chain fatty acids, immune system by altering the gene expression, and by metabolism, by influencing intestinal calcium absorption, increasing the villus structure, increasing the surface area of the small intestinal epithelium, and enhancing the expression of calcium binding proteins. Now also they have got a action on lower the pH of the intestinal cavity, improving mineral solubility and making calcium more readily absorbed. And also they have these short-chain fatty acids participate in indirect regulation by modulating insulin-like growth factor, leading to higher bone formation rates and a trabecular bone matrix. And also they stimulate Treg generation, ensuring immune homeostasis. So many things are done by these short-chain fatty acids, which are produced by our gut microbiome. And not only that, they also have got an effect on endocrine system. By releasing the polyamines like humic acid, spermidine, they modulate the gene expressions. They promote the epithelial cell proliferation, maintain intestinal mucosal barrier function. They have action on the serotonin. There are two types of serotonin, brain-derived serotonin, gut-derived serotonin. Bone-derived serotonin promotes bone formation and gut-derived serotonin inhibits. And also it has got, leptin also has got, but leptin has got a bad effect. Inflammation and bone loss. Chronic low-grade inflammation increases osteoclastic activity. Gut imbalance can increase intestinal permeability, leaky gut. That means they allow inflammatory molecules into circulation. They elevate the cytokines like TNF-alpha and interleukin-6. And this response, inflammatory environment, accelerates the bone resorption and contributes to osteopenia and osteoporosis and delays fracture healing. So this is the leaky gut. That means intestinal dysbiosis is linked to this increased permeability, which is marked by decrease in the protein component of the intestinal tight junctions. Now, The permeable gut facilitates the translocation of harmful microorganisms and microbial components into the systemic circulation, which can then reach the other organs, including bones, and modulate their function. And also there are lipopolysaccharides, which are also stimulate the production of pro-inflammatory cytokine macrophages, colony stimulating factors. All these are create an inflammatory environment. So what are these bad microbiomas? Yes, segmented filamentous bacteria, bifidobacterium, and Agathina alena, they're all causes inflammatory environment. This is called dysbiosis. It has have an effect on osteoporosis, and it also affects the calcium absorption and dysregulates the osteoclast activity by increasing the serum levels of IGF-like things. They reduce the bone strength and quality and influence the osteoprotogerin receptor also through the Rankel pathway. So the chronic inflammation, the dysbiosis, all these things causes bad effect on the microbioma, or bad microbioma causing lesser absorption and interface with what are the important for our bone health, like the hormones and immune mechanisms. So Treg cells and interleukin, they suppress, these are the good ones, they suppress osteoclastogenesis, they enhance bone formation, and they secrete anti-inflammatory cytokines like interleukin 4 and 10, and tumor growth factor. It's essential in regulating and promoting osteoblast proliferation and early differentiation, so enhances bone matrix formation. They can also induce CD8 T cell promoting bone formation. So these interleukins, these are the good interleukins produced by good and microbiome, gut microbiome. So this osteoimmunology is going to be reach a very big place, because this is the cause for the pathogenesis of various bone conditions, not only osteoporosis, rheumatoid arthritis, psoriatic arthritis, periodontitis. The whole osteoimmunology is going to gain now the recent importance. What are the clinical relevance? Emerging research suggests that the probiotics may slow bone loss, prebiotics enhance mineral absorption, dysbiosis is linked with osteoporosis, and gut-targeted therapy may support fracture healing. Conditions like irritable bowel syndrome, chronic antibiotic use, and poor diet, they can negatively impact both gut microbioma and in relatively bone health also. So this is why there is so much importance with the gut microbioma to the bone health. Literature survey says that there are elevated serum levels of TMAO. They were associated with a higher risk of bone fractures and osteoporosis when they have added a subspecies of bifidobacterium, a good gut microbioma, as an adjuvant therapy for a postmenopausal osteoporosis. They have noticed a very good effect on the management in the osteoporosis. Now, the intake of different dietary nutrients such as protein, fat, carbohydrate, and adoption of different dietary patterns like Western diet, vegan diet, Mediterranean diet, all these things which you see the probiotics and the prebiotic dominance in whichever diet is there, that is more helpful for our bone health. Practical recommendation for bone-friendly gut health is a high fiber diet, vegetables, fruits, legumes, fermented food. Somebody was asking what is a good food. Then adequate protein intake and limit ultra-processed fruits, avoid unnecessary antibiotics, and maintain vitamin D levels. So probiotics improve the gut microbiome diversity and makeup. Probiotic microbial strains cannot flourish in our own gut. So you have to go on supplement the probiotic. You cannot just give one course and say that it's enough. Prebiotics give energy to the probiotics. So it's important to consume prebiotic fiber, which gives gut microbes the energy they need to grow and multiply, whereby we will gain more health. The future directions are alterations in the gut microbiota have been connected to many of the factors like all gut immune function, intestinal barrier function, etc. So a number of studies are also indicating that the dietary factors, including Probiotics, prebiotics, vitamin D, calcium, phytoestrogens play a great role in bone metabolism currently, and there is a growing evidence on the association of dietary patterns along with the treatment. So the American Gut Project found those who ate more than 30 different vegetable products per week, they have more diverse gut microbiome, which are positive for our bone health, and than those who ate only 10 types of vegetables in a week. So let us start eating more number of vegetable items and the plant products per week. So in conclusion, inhibition of this T cell trafficking from the gut to the bone marrow with the butyric acid, directly or indirectly, prebiotic and probiotic supplementation may represent new strategies to prevent bone loss or stimulate bone absorption. So with this, I end my talk. Take-home message is a diet rich in fiber, fermented dairy product and polyphenols is the simplest and primary means to cultivate a diverse and substantial microbial composition in the gut, influencing bone health and well-being. The proverb is that the health is the main thing rather than the medication. So if we internally, if we improve our own gut microbiome, that will take action. Of course, in a severe osteoporosis and all that, we must give medical management definitely, but it's definitely going to serve us in the bone metabolism. Thank you very much.
Thank you, Dr. Lakshmi. You elaborated so nicely about the prebiotic and postbiotic, because in general public there is not, they didn't differentiate between prebiotic and probiotic. So you explained very nicely.